Okay, well, I won't take too much of your energy, okay? I'll go easy on you. Light, please. Thank you. Log equations now. Okay, so we're going to continue with what we had previously, except this time logs are going to have a more important role. Okay, so before I start, a little fact to remind you. If you have log of something, it's important that that something is a positive. So sometimes in the exam you get questions like this. When is log 2x plus 3 defined? And the answer is when 2x plus 3 is positive. Or in other words, x is bigger than minus 3 over 2. That's important to remember. So important that sometimes it's a question in the exam for like 1 mark. A short question. Okay? So I just want to state that again before we start looking at these equations, and now we'll have a look at the equations. Oh, and Jerry, not everybody has a chemistry exam next. The business students don't. Yeah, because they're business students. I don't know. Careful what you wish for. Business students, do you have an exam today?
Yeah.
What exam?
Yeah.
That's it?
Yeah.
Trust me, you're better in engineering. Okay. Let's have a look at some examples now. Okay, so for example, solve 4 power x equals 9. Now, we can't really do this the same way as last lesson, because look what happens. If I change this into 2 squared x equals 3 squared, I get 2x equals 3 squared. And this is no good, because I can't say 2x equals 2, because these are different. It's a problem. But what I can do is I can use logs. So I can put a log here and a log here, and then I can say x log 4 equals log 9. So x equals log 9 over log 4. Can someone hit that in on the calculator, please, and tell me what you get? One point. Yeah. Again, it depends on the question. So if the question asked for the exact answer, you should stop here. If they didn't ask for the exact answer, if they just said, what's the answer, you should stop here. I know, but often here is fine for both. We see sometimes the question would say, solve to 3 dp. Sometimes the question would say just solve, and sometimes it would say solve and find the exact answer. So when it's like this, obviously you have to go 1.585. When it's like this, you have to say log 9 over log 4. And when it's like this, usually both answers are okay. Yeah. Okay, let me give you one to try now. Solve 6 power x equal to 3. Okay, do you have an answer? What's wrong? Okay. Right, so we have log on both sides, log 6x, give it a sec, equals log 3. So x log 6 equals log 3. So x equals log 3 over log 6, which is minus or 0. 3. Yes. Okay, good. Right, let's have a look at another example now. Let's make it a little bit harder. So, next example, we'll say 6 power x minus 4 equals 9 power 3x plus 7. Like this. So it's the same method as previously. We have log 6x minus 4 equals log 9 3x plus 7. The x minus 4 comes down in the front. Log 6 equals the 3x plus 7 comes down in the front. Log 9. Expanding, I get x multiply log 6 minus 4 multiply log 6 equals 3x multiply log 9 plus 7 multiply log 9. So I get x log 6 minus 3x log 9 equals 4 log 6 plus 7 log 9. There's an x here, let's take it out. X log 6 minus 3 log 9 equals 4 log 6 plus 7 log 9. So now finally I get x equals exactly 4 log 6 plus 7 log 9 over log 6 minus 3 log 9. Easy peasy, huh? And when you're ready, if you could type that in, please. What you get? Thank you. Okay. Can I scroll down? Not yet, okay. Continue. Okay. So let me give you one to try now. That's like this one. So I want you to solve this for me. Solve 8 power minus x minus 5 equals 7 power 4x minus 6. Give that a try, please. Okay, do we have that yet? Yeah? Shall we look at it now? Let's have a look. So just like previously, log on both sides. So log here and log here. I get minus x minus 5 log 8 equals 4x minus 6 log 7. Okay, so that's minus x log 8 minus 5 log 8 equals 4 log 4x log 7 minus 6 log 7. Okay. Minus x log 8 minus 4x log 7 equals 5 log 8 minus 6 log 7. Okay. X minus log 8 minus 4 log 7 equals 5 log 8 minus 6 log 7. So finally, x equals 5 log 8 minus 6 log 7 over minus log 8 minus 4 log 7. Okay, what is that, did you get? 130? Okay, 1296 we'll say. Yeah. Okay, once you write that down, we'll have a look at another example here, onto something different now. Okay, Continue. Yeah? Okay. Let's try this one now. 2e2x minus 9ex plus 6 equals 0. Okay, so you can all see what's happening here. It's a quadratic. Does it have factors? Well, it has to be a 2ex and an ex. I need it to be a 6, so I can go with 6 and 1, which is no good, or 3 and 2. 3 and 2? 6, 7, no. Formula? Ex equals minus b plus minus square root b squared minus 4ac. 4 times 2 is 8, 48, is it? All over 4? Is that right? Is that right? Yeah? Ex equals 9 plus or minus root 33?
Yeah.
Yeah. So I get two answers. X equals log 9 plus or minus root 33 over 4. Two answers here. Okay, continue. Now, the next thing I want to show you, it's a useful thing to be able to do in maths. When you have something like this, 2 power 3x plus 4 as an example, it's always possible to write it in this form. A, E, K, X for some A and for some K. So we don't know the A and we don't know the K. But it's possible to find A and K, and that's what we're going to look at. So firstly, to find the A, well, that's easy, because actually, before I just show you that, just to make sure you understand the difference here, because really, I shouldn't say this, I should say this. You know this symbol? So what's the difference? If I say something like, I don't know, x plus 2 equals 0, then you can solve and you get x equals minus 2. If I say x plus x is equivalent to 2x, we can't solve this. There's nothing to solve. You don't know x. So there's a difference between this and the difference between this. In the first case you can solve it, and in the second case you can't. It's just a identity, a fact. These has advantages and disadvantages. So of course the advantage here is that you can solve, and that's a disadvantage here. But this has an advantage, and the advantage here is that this is true for any x. So if I use x equals 3, I'll get 3 plus 3 equals 2 times 3. This is still true. It doesn't depend on the x. I could do the same thing with 13. It's still true. This is called an identity. This is called an equation. This is called an identity. Key difference. So, going back now to my question. Can I scroll back? No, I see people writing. Yeah. Scrolling back. Okay. This is an identity, which means it's true for any x. If it's true for any x, then it's still true if x equals, let's say something like 0 maybe. So that means 2 power 4 should still be the same as AE0. Now you can see, that's why I chose 0, because I can clearly see what the A is. What's the A here? 16, which is useful. Just like if I go back here, if I said x plus x is identically some number times x, I can find this number by just choosing a value for x. So if I choose x equals, let's pick any number, 5. 5 plus 5 equals some number times 5. 10 equals 5a. What does a equal? 2. But of course it's 2. You could have told me that at the beginning. It's 2. So I'm doing something very similar over here on the other side. I'm choosing a value of x for this identity. So now I have 2 power 3x plus 4 equals 16ekx. Okay, so the next job is to try and find the k. Not as easy as the a, but not impossible. I can do it the same way by making a choice for x. I can really choose anything, but what would be a convenient number to choose for x? I already chose 0, so I need to choose something else. Yeah. This is still true if x equals 1. So I get 2 power 7 equals 16 power e power k. What's this now? 2, 4, 8, 16, 32, 128? 128 equals 16 ek. Is that 7? 8. 8 equals ek. This isn't so bad. How can I get the k now? Yeah. Log 8 equals log ek. Now remember, this is log base e8 equals log base e ek. So e to what power makes e power k? K equals log 8. So now we have k, it's log 8. Now we can leave it as log 8 if we want, or a decimal. So I'm saying that 2 power 3x plus 4 is the same thing as 16 e power log 8 times x. Let's test it. Let's test. So let's check it with something like x equals, I don't know, 2. Let's see what we get. On the left, I'll get 2 power 3 times 2 plus 4. So I get 1024. Okay? Let's test it on the right. 16 e power bracket log 8, close the bracket, multiply by 2. I should get 1024. And I do. So we've rewritten our exponential into the form containing e. This actually is quite a useful thing, because later we'll see that problems like this are much easier to deal with than problems like this. For example, you don't really know the graph of this, but you do know the graph of this. Because this is a positive and this is a positive, the graph will look something like this. And this point here will be 16. So that's already one advantage. Okay, write this down. Let's have a look now at a harder one. Can I scroll down? Okay. Solve log x2 minus log 2x equals 3. Okay. Continue. Shall I solve it now? So the very first thing you do before you start is you have to check when x is defined. Let me just give you another example just to maybe make it a bit clearer. So suppose I said log, I don't know, 4 9x plus 1 minus log 2 6x plus 2 equals minus 1. Before you solve that, you need to know what the x could be. So here we can only have 9x plus 1 bigger than 0. And here we can only have 6x plus 2 bigger than 0. So x must be bigger than minus 1 over 9, and x must be bigger than minus 2 over 6, which is 1 over 3. Now the and is important here. So which is the ultimate one? Yeah, x must be bigger than minus 1 over 3. Because if x is bigger than minus 1 over 3, no. X must be bigger than minus 1 over 9. Because if x is bigger than minus 1 over 9, it's also bigger than minus 1 over 3. So this one here gives you both. And then you can solve. But at the very end, when you get your answer, you need to check if it's okay. You must do this in the exam because you will lose marks if you don't check if your answer is okay. Because sometimes you get 2 answers but only one of them is right. So let's go back to my question now. Okay, can I scroll to the right? Yeah? And we'll come back to this one in a moment. Okay, so let's look at this one. Here I need x to be positive, and here I need x to be positive, so that means together I need x to be positive. Okay, well that's easy, so I need x to be positive. The big problem with this is you have an x in the base and an x in the argument. So we need to use one of our rules to fix that. We can use the rule that lets us swap the x and the 2, and then it's just 1 over. So this is 1 over log 2x minus log 2x equals 3. I forget which number rule this is. Rule 4, I think. Is it? Rule 4, I believe. Now what you notice is that this is the same as this. So what you can say is you can call u log 2x. So now we get 1 over u minus u equals 3. What's next? What should I do next? Multiply by u. So now I get 1 minus u squared equals 3u. So I get u squared plus 3u minus 1 equals 0. This we have to use the formula, it looks like. So using the formula, we get u equals minus b plus or minus square root b squared, which is 9 minus 4, which is a 5. Is it like this? Oh, it's 9 plus 4, sorry. So that's 13 then, thank you. Good. But we're not looking for u, we're looking for x. So we have to remember that u was log 2x equals minus 3 plus or minus root 13 over 2. Remembering that this means the same thing as saying, 2 to the power of minus 3 plus or minus root 13 over 2 equals x. Or to be extra clear, you get x equals 2 minus 3 minus root 13 over 2, or x equals 2 minus 3 plus root 13 over 2. Now both of these answers I know are positive, so they're both okay. You don't need to reject any of them. Okay, so I'll give you one like this to try now. These are getting harder. Can I scroll down? Yep. Okay, continue. Now, what I want you to try, which I'll do in a minute, is the one we were talking about a moment ago. So I want you to solve this. Log 4, 9x plus 1 minus log 2, 6x plus 2 minus 1. And you already know your answer should be bigger than minus 1 over 9. We've already checked that. So now I want you to try and solve it. Make sure your answer is bigger than minus 1 over 9. Okay, I'll give you a minute. Solve this now. Nearly finished. Okay, shall we look at it now? Let's have a look. Okay. So the first problem here is that this base is a 4 and this base is a 2. We need to make both bases a 2. So we have to use the fifth rule of logs. If I change this to base 2, the price I pay for that change is I divide by log 2 4 minus log 2 6x plus 2 equals minus 1. Okay, let's get that out of the way. Now, log 2 4 is 2, so this is a half log 2 9x plus 1 minus log 2 6x plus 2 equals minus 1. Okay, so next I'll bring this up to the top. I'll have log 2 9x plus 1 power a half minus log 2 6x plus 2 equals minus 1. After all that, I can now put these together using the second rule of logs. So I have log 2 9x plus 1 square root, because it's power a half, all over 6x plus 2 equals minus 1. Which I need to remember is the same thing as me saying 2 to the power of minus 1 equals root 9x plus 1 over 6x plus 2. Because that's what log means. So that's 1 over 2 equals root 9x plus 1 over 6x plus 2. Now don't say anything. Sean, what's this called? Make me happy. Oh, you made me so happy. Thank you. Thank you. Okay, so we cross multiply. So I get 6x plus 2 equals 2 root 9x plus 1. Yeah? Okay, next I should divide by 2. So I get 3x plus 1 equals root 9x plus 1. Okay, what should I do next? Square. 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 So I get 9x squared plus 6x plus 1 equals 9x plus 1. 9x squared minus 3x equals 0. Divide by 3. 3x squared minus x equals 0. Factor out x. x, 3x minus 1 equals 0. I get two answers. X equals 0 or 1 over 3. And both answers are fine because they're both bigger than minus 1 over 9. It's hard. It's a hard one. These are hard questions in the exam.
What if we divide 9x here minus 3x over here? What about?
Which line? Here? Up?
From
1, 2, 3, 4. Fifth, yeah.
What's dividing by 3x?
No. Not allowed, because if you divide by 3x, you can only divide by 3x if you know that x is impossible to be 0. But you know that it's possible to be 0 because at the start, don't worry, I'll go back. At the start we said x is bigger than minus 1 over 9, so you know it's possible to be 0. So you're not allowed to do this because you don't know it can't be 0. You can divide by 3 because you know 3 can't be 0 because it's 3. But you can't divide by 3x because you don't know if it's 0 or not. Yeah. And I think if you did that, KJ, it means you would miss this answer and you would have only this answer. Okay, write this down, please. Be strong. Okay, let me give you which questions you need to do and then you can go. So, 3AB, 4AB, 5A, 6ABC, Oh, come on. It's good for you. It's good for you. Did we get Dennis in the end? No, he's still missing.